to Pale Blue Pod, the astronomy podcast for people who are overwhelmed by the universe but want to be its friend.
It sure is. Hi, everyone. I'm Dr. Moiya McTier. I'm an astrophysicist, a folklorist, and a friend to the universe. And I want to make other people be friends with the universe, like my bestie and co-host.
That's me. I'm Connie. I am your co-host, and I am overwhelmed by the universe. So I'm glad to have Moiya here to help me be its friend.
Oh, yes. Well, you help me navigate stuff on Earth, so I can help you navigate stuff off of Earth. It's a, I think, very fair trade.
Oh, yes, yes. It's funny because I am a Taurus, so I can ground you, bestie.
You do, and you do such a good job. Thank you. I'd actually love to have some of your grounding help today.
Okay.
I am preparing a lecture, as I do here at the Podiversity, but it's a lecture on the origin of life, and I don't often talk about that. I talk about searching for life.
Right.
And I will incorporate that into the lecture, as you'll see, but I'd just love to get your feedback on it. Can I give the presentation to you and you interrupt me when you think I'm being unclear or when the students might get a little confused?
Yeah, totally.
Awesome.
I'm very excited.
Awesome. I think you'll like it, bestie, because I am going to bring in more mythology to this lecture.
The fans may not know. They may not know, but I've been asking for this. So this is a treat as much for me as it is for everyone else.
It is. It is. So I'm calling the lecture Seeds of Life, Mythology Meets the Cosmos. And I'm doing this lecture now because it's springtime. And we love that. We love the season of life.
Finally.
Yes. Winter was rough. And so now it's nice to be heading into spring.
Mm-hmm. Indeed.
Do you know when spring started, bestie?
It was March 20th, and I believe it was around 10:45 a.m. because I texted you around 1 p.m. wondering, is it spring yet?
Yes. I love that you knew there was an exact moment that the equinox happens.
I do. And I usually don't care, but when your bestie is an astrophysicist, it's like, oh, well, actually.
Actually, yes.
I will care.
I think it's fair, it's fine to celebrate the whole day, but we can narrow it down to the exact moment. And that's because there's a mathematical there's a quantitative time for when it is the equinox. We have talked about this many times before, so we know that the changing of the seasons has nothing to do with what?
The distance from the sun.
Yes, exactly. And instead, it has to do with
the tilt of the Earth along its axis.
Bestie, I'm so proud of you. Exactly. Yes. So we are tilted away from the vertical. Our rotational axis is tilted away from the vertical by 23.5 degrees. That changes over time. Over many thousands of years, it goes between like 23 and 24 degrees. But right now it's at 23.5. And whatever hemisphere you're in, if it's your winter, that means your pole is pointed away from the sun. And if it's your summer, that means your pole is pointed towards the sun, which means at some point between pointing towards the sun and pointing away from it, it does have to be totally perpendicular to the sun. Mm-hmm. And the moment where it's totally perpendicular is the equinox.
The equinox, yes, because it's equal.
It's equal, yes. And then another way to think of this is in how much sunlight, how much daylight you would get at that time of year, wherever you happen to be on Earth. And the equinox is the day that pretty much every place on Earth gets 12 hours of daytime and 12 hours of nighttime. If you deviate from the equinox, then your latitude really determines how much sunlight you get on a given day at a given point of the year. And the higher you, the higher you are in latitude, so by the time you get to 70 degrees north or 70 degrees south, you have really extreme variation. So in the summer, in like around the solstice in June, if in the northern hemisphere, you would have 24 hours of sunlight. And in your winter, you would have 24 hours of nighttime. Pretty extreme.
Yeah. Midnight sun? Like, because it's sunny at midnight in one of the, or is it both poles? Both poles can have midnight sun?
Yeah, both poles during their summertime.
Nice.
Yeah.
Well, maybe not.
It definitely
I don't
does
know.
mess with their circadian rhythm.
Yeah.
My dad and I visited Iceland in June in 2014, and I'm pretty sure we stayed in the northernmost hostel. So my dad, who was this like big ice mountain man, he loved being in the cold. He took a hike to the Arctic Circle, or like really close to it, and couldn't have been me, but he said it was very pretty.
Couldn't have been me either, but it does sound very pretty. I mean, maybe one day you and I will get bundled up and we can go. Because the aurora, like there's stuff to see.
Maybe. You're right, the Aurora. I would go for the Aurora, but we're staying in one of those like fancy glass
Yurts and
containment
stuff,
thing. We're glamping.
We're glamping. Okay, great.
My father knew not what a glamp was. But speaking of Arctic circles, I have a question for you, bestie.
Mm-hmm.
Which place on Earth, this is multiple choice,
okay,
do you think gets the most amount of sunlight, the most hours of sunlight over the course of a year? You have three options. Do you think it's the northern Arctic Circle, the equator, or the southern Antarctic Circle?
Okay. I'm gonna go with equator. But I feel like it's too obvious. But the equator always gets 12 hours of sun.
It always gets 12 hours of sun.
Some places get more than 12 hours of sun, but then they also get less than 12 hours of sun.
I see you doing the rough math in your head.
Yeah.
It's a good guess.
I'm going to stick with the equator.
Yes,
because
that is the logical
minuses.
guess. You, however, would be wrong.
Womp.
Womp. That's okay. I would have gotten that wrong too. It's actually both of the circles, the Arctic and Antarctic circles, that get more sunlight than the equator, and the Arctic Circle in the northern hemisphere gets the most sunlight of all. The north gets more than the south because during the northern hemisphere's summer, we are farther away from the sun by like 5 million miles compared to our closest approach in the sun during the southern hemisphere's summer. And because we're farther away, we are moving more slowly. So we spend more time out here, and the northern hemisphere's summer ends up being about a week longer than the southern hemisphere's.
Interesting.
So that's why the north is more than the south, but the circles, they end up getting more sunlight than the equator because they have that midnight sun, and that like edges it up a little bit. But their sunsets are also much slower than a sunset at the equator because you are seeing the sun at a steeper angle. You have to like look down closer to the horizon, so it has to travel a larger angular distance from your perspective, and it also will like just kind of move along the horizon, especially during when you get closer to the solstice times of year. So there's a strong peak.
This makes sense. I've moved from New York to Florida, but I've had family in Florida. And even just that distance in the States, like the sunset times can vary across the year. So my cousins, when I lived in New York and they were in Florida, the sun sets later. But knowing that the sun also sets slower at the poles.
Yeah, like to the Arctic Circle, at the circle, yeah.
That's fascinating, of just like how the sun takes longer to set. I never thought about it having a differential per latitude.
And all of this extra sun that we get when we are at the equinox and heading towards the summer solstice, that brings out more plants. And because animals know that there's now more plant life, more food around, they start having babies. So you see little baby chicks and ducks and bunnies going around, and thus spring is the season of life. And for thousands of years, our ancestors noticed that this was the season of life, and they tried to come up with explanations for it. And a couple of my favorites have to do with returning from death, or returning from the realm of the dead. I'm going to highlight two stories here. One of them I know you're familiar with. This is the story of Persephone. Where does Persephone rank for you in Greek mythology figures?
I'd say she's pretty high in terms of, I've read a lot of like different adaptations of her story, so a little more familiar with it, although not like the direct Greek text. Yeah, and because she's like the goddess of spring, spring's my season, so
Nice.
I do have an affinity for her.
She is one of the more popular, one of the more commonly discussed figures from Greek mythology. She's the daughter of Zeus, king of the gods, and Demeter, who's the goddess of agriculture and grains. And Zeus's brother, Hades, so therefore Persephone's uncle, fell in love with Persephone and decided he had to have her, and called up Zeus, his brother, and was like, hey, bro, remember that deal we made where I get to marry one of your daughters? I'm calling that in. So they hatched a plan to distract Demeter while Demeter and Persephone and their nymphs were out collecting something from the forest. And they lured Persephone away and Hades took her down to the underworld. There are different versions of the story. So in some of them, she falls in love with Hades. In some of them, she's just like tricked into staying. But she does eat some pomegranate seeds, and that kind of traps her into this deal that her mother, Demeter, begs Zeus to make. And so while Persephone's been gone, Demeter has been roaming the earth looking for her daughter. And because she's the goddess of grains and agriculture, she is no longer doing those duties. So the crops die and there's no food and the plants are dying. And that is how they explain winter. And so she brokers this deal with Zeus and Hades where Persephone gets to spend 6 months up here and 6 months down in the underworld. And while she's in the underworld, Demeter always gets upset and she always lets the plants die. And so it really is this Persephone's return from the underworld that brings or triggers spring. And I think that that is really similar in a lot of ways to the myth of Isis and Osiris in Egyptian mythology.
Yeah, I'm a little
Have you heard
familiar.
about this as much?
Not as much, no. I know I've heard of the names, but I don't always remember what their domains are.
Yeah. Egyptian mythology is tricky because it changes so much over the long history of ancient Egypt, but I'll give one of the more popular versions here. So Isis and Osiris are brother and sister, but they are also husband and wife. And there just weren't many people to choose from. This is very early on in the cosmos.
Yeah,
it happens.
It's always related.
Yes.
Yeah.
You just got to get used to it if you're going to study mythology.
Yeah, especially as far back.
And Osiris is the king of Egypt, and their brother Seth is jealous. So he murders Osiris, chops his body up into a bunch of little pieces, and scatters them across the world. Your reaction is appropriate. Isis is bereft, so she goes searching for the pieces and finds them and puts them back together and then uses her healing magic because she's the goddess of healing and magic and wisdom. She uses her magic to bring Osiris back from the dead. The way this connects to spring is that Egypt doesn't really have the same 4 seasons that we do, but they do have a growing season that happens after the Nile River floods and enriches the soil with the nutrients that are brought down from the south after monsoon rains. And right before the Nile River floods every year, the star Sirius comes above the horizon in the morning, and they started to associate Sirius and the flooding of the Nile, but they didn't call it Sirius. They called it Sopdet, and it was associated with the goddess Isis. And so they had this story where Sopdet/Isis, this star, is crying tears as Isis is going around trying to find the parts of Osiris's body. And once she does, she brings him back, and then Osiris, coming back from the dead, brings life back. Right? The Nile brings life back to the fields. And I just really love that parallel where you're explaining the season of life by saying that things are coming back from the dead, which is what winter is often associated with. But these are just the small cycles of life. These are how we explain the seasons, but not how we explain the origin of life altogether. And that is one of the more interesting questions that astronomy can answer, and one of the questions that mythology has tried to answer for a long time. So I'm going to share a couple stories with you about how people thought life started, and both of them have to do with crafting humans from clay. We're going to go back to our Greek buddies for the first story. Do you know who crafted mortals in Greek mythology from clay?
From clay, I don't remember that one.
It's Prometheus. Before he brought us fire, he was tasked with making humans from clay by Zeus. So Prometheus and his brother Epimetheus were working together, and Epimetheus made all of the animals, but took the useful skills and the useful tools like horns and talons and fangs. And so when Prometheus was making the humans, there wasn't anything left. And I think that made him take pity on us because he kept trying to help us in the face of the gods. He made sure that we got meat in the deal of sacrificing offerings to the gods so that humans got meat and the gods got the bones and the fat. And almost in retaliation, Zeus was like, okay, you can have your meat, but you can't have fire to cook it. So he took fire away from the mortals, and then Prometheus had to steal it back and give it to him. And it was after that he was punished for helping the people.
Yeah, I knew about the fire and the bird, I guess, pecking out his liver, but I forgot that he created humans from clay. It's interesting the way that, like, as someone who grew up Christian and reading like the Bible, like the Genesis story does also have this like dust to dust, like dust and clay, like forming man out of the earth thing. It's cool that it goes across culture.
Yes, we are people of the earth. And so there's this other story from a Yoruba story that talks about the beginning of creation and how there's the ocean below ruled by Olokun and the realm of the Orisha above, and Olorun and Obatala and Oronmila, they all live in this realm above. But Obatala especially is really bored of looking down below and just seeing water as far as the eye can see. So he begs Olorun, the creator spirit, to let him make land. And so Obatala has to do kind of a scavenger hunt list of tasks to make this happen. He has to collect a bunch of gold to make a chain so that he can climb down from the world above. He carries some sand in a giant snail shell, and he brings with him a chicken and a seed for a date palm tree, so a date palm nut. And when he's partway down the chain, he drops all the sand, and then he drops the chicken immediately after so that the chicken can scatter the sand around and make the land mass bigger. And then he plants the date palm nut.
So the chicken came first.
Well, I imagine there might have been eggs up in the land above. But also the answer to that is eggs, because dinosaurs laid eggs before there were chickens. So while he's waiting for this date palm tree to grow, he starts fashioning companions out of the silt, out of the water in the sand. And he's like making them, giving them little arms and legs. And then the tree grows, and he makes some wine out of its fruit. And he's drinking and crafting and drinking and crafting. And as he gets drunker, he keeps forgetting to like maybe put a leg on one of them, or like one of them is just like a little bit shorter than the others. And he keeps making these figurines, and because some of them have differences, that is how the myth explains people born with physical differences. So Obatala becomes the Orisha who oversees or cares for people with physical differences.
Oh, wow. Huh. Yeah, I know Hephaestus has a disability in Greek mythology, but it's rare, I think, to hear about that, at least from my perspective.
Yeah. And what I like in both of these stories is that after the figurines are crafted, someone else breathes life into them. So in Greek mythology, it's Athena, and in the Yoruba myth, it's Olorun, the creator spirit. So that's how some myths have explained the origin of life, but astronomers have been trying to figure out how we can find life for the last 60 years at the very least. And we've come up with a nice checklist of things to look out for. So I have here a little habitability checklist from the big scales to the small scales.
That's pretty big.
So if you're looking for a place in the galaxy where life is likely to form, then you want to be far from dangerous radiation sources. So you want to be far from where there's a high concentration of stars. In our galaxy, we know that about 30% of the stars are trapped in the central bulge, so we probably are going to avoid that. That's a big red zone. At the same time, we want to be where there are a lot of heavy elements like the carbons and nitrogens and oxygens that make us up, even the irons and nickels that make up our planet. So we want to be near a lot of stars because those stars produce the heavy elements in their cores, at least the heavy stars do, and then they explode a supernova and send those elements out into the interstellar medium to be used in the next generation of stars and planets. So we know that in the galaxy, there are fewer heavy metals, heavy elements as you go towards the edge of the galaxy. So we probably want to avoid the outer edge, which leaves us with this little green ring around the Milky Way. But we have to be even more careful because our orbit has to be stable over many billions of years. You don't want to be passing in and out of the spiral arms over time because those spiral arms are high density areas. So our sun is actually smack dab in the middle of the galactic habitable zone because it is in between the center and the edge. So it's in that green ring. And we have a special orbit that will almost always keep us on the outside of one of the spiral arms. Like as the spiral arms move, we will stay outside of them instead of moving in and out because the spiral arms aren't always made up of the same stars. It's more like a traffic jam than a sausage where when you're in a traffic jam, the cars are moving through the jammed spot.
Right.
Like that bottleneck, depending on what causes it, it might move forward a little bit, but the cars are moving through it faster than the jam itself moves.
Oh, wow. That really helped.
Good.
Yeah.
Okay, good. Thank you. That analogy comes to me direct from my fluid dynamics class because we spent a lot of time talking about traffic stops and comparing it to the motion of stars and like gases and stuff.
Whatever works.
Thank you, Lorenzo. He was my fluid dynamics professor.
I love a good earthbound analogy.
So that's where you want to be. When you're talking about the stellar scale of habitability, you want to be the right distance from your star on a planet. You want to be on a planet the right distance from the star that liquid water could exist, or at least that's what astronomers are looking for. We call this the circumstellar habitable zone or the Goldilocks zone because it's the place where the temperature is just right for liquid water. If you're any closer, the water evaporates. If you're any further from the star, then the water freezes.
Right.
You also don't want to have too much magnetic activity. I didn't really pay much attention to this in my research, but if you are around a very young, low-mass star, they tend to give off a lot of flares, which could be difficult for early life forming, or it could kind of kickstart evolution and genetic mutation. So it really goes either way. The jury's still out on this. But if you want to simplify things, probably avoid those types of stars. And on the planetary scale, there's a lot you can think about. You want to have an atmosphere to, provide some heat and protection. You want a magnetic field also for protection from things like charged particles coming off of your star. A moon can help give you tides. And one thing we've learned is that life on Earth formed in the water and was helped a lot by tides moving things around. So that's just good stuff to have.
Oh.
That's the checklist. It's long and it's involved and life probably isn't everywhere because we've looked some places and we haven't found it. But I don't think this is asking too much. So I do believe there is life out there.
Yeah. Seems reasonable.
In mythology, they think about life being out there. In Norse mythology, they have a cosmos where there are 9 different worlds, and they all are nested in the branches of Yggdrasil, the world tree, which is like the cosmos. Like instead of a vast empty space, their metaphor for the universe was a massive tree, which I love because I'm totally a tree girl. And Norse mythology has its own idea of the Goldilocks zone. Whether they know it or not, they totally understand that life forms in the place where the temperature is just right, between too hot and too cold. Two of their worlds, the first 2 worlds to form in the branches of Yggdrasil, are Muspelheim, the world of fire, and Niflheim, the world of ice. And the first living creature to form in Norse mythology is Ymir. Ymir is this genderless giant who forms in the place where the ice is melted by the fire. And then the second life form to come into being is a cow named Aldumla, and Ymir drinks from Aldumla. Like that's how Ymir sustains themselves. But there is no freaky business going on, in case you were worried.
Okay, because I was very concerned.
No.
I feel like
No.
the Greeks have gotten... The Greeks made me think of it.
Well, yeah, because Zeus be fucking cows.
Yeah.
Ymir is not Zeus.
Okay, good to know. Good to know.
No, so Ymir does generate offspring, but only with themselves. They like rub their legs together, and out of their knees pop some giants, and a few other creatures are born in similar ways. And some of those giants have children, including Odin and his two brothers, Vili and Ve, who then turn around and kill their grandparent. They murder Ymir and turn Ymir's body into Midgard, the world or the planet where humans live. And then, so that's three of the worlds right there. Muspelheim, Niflheim, and then Midgard in the middle. And then there are 6 other worlds that are referenced scatteredly throughout Norse mythology texts, but there's Asgard, where Odin and Thor and the other Aesir live. There's Svartalheim, where the dwarves live, and Jotunheim, where the giants live. So there are all these different worlds for different creatures. So they do imagine that there are other worlds with other life forms. So basically aliens.
Yeah, that's why I guess Thor and Loki made it to the MCU. Like it was really easy to like translate it into space travel and like adventure, quantum, like space adventures and stuff.
Exactly.
That's cool.
And I had a lot of fun imagining how the 9 different worlds in Norse mythology would map onto the planets in the solar system. I did that on the very first episode of Spirits that I was ever on. I had actually just started making exolore after COVID started, and then I reached out to them, and this was one of my suggestions for an episode. So check that out. It's Norse Cosmology with Moiya McTier on the Spirits podcast. It's in the research notes for patrons.
Nice.
Hey everyone, it's me. Connie is checking on some slime molds that we've been growing in my office for the last couple of weeks as I prepare for this lecture. So I'm going to take this time while she's looking at those to share some messages with you. The first is a big thank you to all of the patrons who support the show financially every single month. We are an independent podcast, so it'd be really hard to make this show without your support. Thank you so much. We also want to give a special shout out to our Sun-like stars, Scott Reynolds, Tom T, Nicole Bartlett, Ashley Shambo, and Bruce Sedloff. Thank you so much for your support. If you want to join this awesome group of people and help out an indie podcast, you can hear your name on the show, you can make it onto the patron star chart, and get research notes for most episodes where you get extra reading and watching resources for extra context on stuff that I didn't have time to include in the show. All of that for $5 a month at patreon.com/palebluepod. You can also make a one-time donation and become a supernova in the Pale Blue Pod sky. You can do that at the PayPal link in the episode description if a monthly donation is not something you can do. And if any type of financial support isn't something you can do right now, we totally understand. Times are hard, and we're not going to fault you for not being out here throwing money around. If that is the case, there are other ways you can help the show grow. You could rate and review us on whatever podcast platform you use, and you can share a link to a particular episode with someone who you think would enjoy it. But no matter what you do, thank you just for listening. Connie and I love being a voice that joins you on your week. So thank you so much. My next message is a podcast recommendation from another show in the Multitude Collective. It's called Simple and Clean. This is a show where the hosts Misha Stanton, who edits Pale Blue Pod, and Mayana Barron talk about Kingdom Hearts, which is a little video game franchise about really big feelings. You can join them as they discuss the plot, characters, world building, music, fashion, fan base, and societal impact of a thing that by all means probably shouldn't exist. And if you're like, why are they saying this video game shouldn't exist? check out the pod. If you've never heard of Kingdom Hearts, that's okay. I hadn't either before they started this podcast. They are there to break it down for you. They'll explain why they love it and hopefully convince you to check it out. Each week, they're going to unravel a different aspect of how the game works and how its fan base works. So they explain everything around the game too. New episodes come out every Sunday, and you can listen wherever you get your podcasts or by checking out the link in the episode description. Okay, Connie is back. She says that our slime molds have had some impressive growth over the weekend, so she's going to turn on their UV lamp, and we'll get back to this conversation. So that's Norse mythology. What does science say about the origin of life? If we look at the long history of Earth and we split it up into different eons, these long periods that really are like climate-wise, they're very distinct. If you look at the characteristics of Earth at these different periods, they're very distinct. But early on, we know that 4.5 billion years ago, when the Earth formed, it was hot. It was molten. It was not a good place for life. And it took about 500 million years for that first eon, the Hadean eon, to end and Earth to cool down enough to be even potentially habitable. We also know that this is around the time that Earth probably had its first oceans. So Earth was born almost, or like very early on, got its first oceans. The water, we are pretty sure, came from asteroids that hit the surface of Earth and carried with it enough hydrogen and oxygen to make oceans worth of water. And we don't have evidence of life that early on, but it could have potentially existed 4 billion years ago. Then we enter the Archean era, and life could have potentially formed then. We see these types of fossils called stromatolites starting 3.5 billion years ago. These are like layers of sedimentary material that would have been produced by photosynthetic bacteria. So very early forms of life. And this is also a very early form of photosynthesis. So we do know that life is, 3.5 billion years old. But it's kind of hard, actually, to define even what life is. Biologists don't necessarily agree, but there is, again, a list of criteria. We scientists love our list of criteria.
Yeah. A checklist.
oh, my kingdom for a good checklist. Yes.
Absolutely.
Life is supposed to be ordered and structured, and cell theory in biology says that the cell is the basic building block of life, but cells, there's a whole spectrum of complexity for cells. We know that life has to process energy and whatever waste products it produces. It could process energy through eating fuel. It could photosynthesize. It can chemosynthesize in the hydrothermal vents at the bottom of the ocean if it wants, but it does need to process energy some way.
Yeah, I don't think I could be on an oceanography podcast because I'm definitely overwhelmed by the ocean.
Yes.
Oh my goodness.
Yes.
So, because you just said what? There are vents at the bottom of the ocean? Yeah. No.
These places where there's like holes too deeper to beneath that ocean crust, and there's a lot of energy, there's heat, there's gas, and it shoots out in these plumes underwater, and they're full of energy. And so there are creatures who live around the hydrothermal vents who get their energy from chemical reactions with that material, and because they don't have sunlight and they don't eat other things.
Wow.
Yeah.
Okay.
And then things eat them. Very cool. You're not yet at the point where you can be comfortable enough with it for it to be cool. I see that.
Yeah, not yet, but I can get there, but not yet.
Yeah, not yet. But so it has to process energy.
You almost had me.
I did. I did. Life has to reproduce in some way. It doesn't have to be sexual. There's a lot of asexual reproduction here on Earth, but most reproduce sexually, and it does need to perceive the world around it and respond to stimuli. It doesn't have to have the same sense as we do, but plants can tell when the sun is up. Plants can tell when there are pests nearby. They can communicate with each other in those ways and manipulate themselves and the environment around them to an extent. So all of those are necessary for life, and we think that started about 3.5 billion years ago. And then life got more complicated. 2 billion years ago, cells turn into eukaryotes. So they have all of these fancy little like pieces inside them. So that's when you get the nucleus in the cell. That's when you get the mitochondria.
I was going to say the mitochondria is the powerhouse of the cell. I was waiting for my moment, to be honest.
Yes. This is also where we get the different branches of life. So the animal kingdom, the bacteria kingdom, the fungal kingdom, it splits up into those different groups. And we are now in the Proterozoic eon, the third eon of Earth. Moving forward by a long time, we get to just 500 million years ago. This is the start of the Phanerozoic eon. This is the Cambrian explosion, where you get this boom in biodiversity. You have plants and animals coming on land from the ocean. So this is when life on Earth starts to look like how we see it now, where there's like the whole planet is now populated with different types of creatures.
I'm picturing that like textbook page where it's like the water creatures like moving outside of the water and turning into land creatures.
Yeah, I think it's the Tiktaalik, that little eel-looking thing, the first thing to come out on land. Yeah. And all the way at the end of the Phanerozoic, 2 million years ago, this is where we get the earliest hominins. This isn't even Homo sapiens. This isn't like Neanderthals. This is the earliest creatures. This is like early apes. It's a long time ago.
Wow.
And so our time on this earth, our form of life, is very new and very young. And yet, we are, as far as we know, the only life forms that are trying to figure out where we started. So we have different hypotheses for it. One of them is that life started natively here on Earth in the primordial soup, as we call it. This is also called the heterotrophic theory, or the Oparin-Haldane hypothesis, named after the two scientists in the 1920s who independently came up with it. The basic idea is that if you have a soup of different molecules where you have some carbon dioxide, some ammonia, you have some oxygen, you should have oxygen. It should be in a soup of water, a water base, because water is known as the universal solvent. It's really good at breaking material down into its base parts and then providing a medium for those parts to recombine. So you get your primordial soup with all of its ingredients, and then to cook it, you need a source of heat. And early on in the Earth's history, that would have been the sun, with its ultraviolet rays providing energy to make those molecules move around. And to stir the soup, because you don't want it to just like collect at the bottom and turn into a squidgy burnt mess, you need the tides. That's what's causing the mixing. And the tides are caused by the moon and the gravitational interactions between the moon and the Earth and the sun also. Without the tides, without the moon's gravitational influence, we might not have started life that early on.
So when you're looking for life, are you mostly looking on planets that have moons? Or, I mean, I guess you'd look anywhere, but you think it's more likely there.
We'll look anywhere. Beggars can't be choosers. But we actually have never found a moon around another planet. We have candidates. We have potential exomoons, as we call it, but they're really small. It's already hard enough to find planets. So finding a moon is, it's literally exponentially more difficult. So that's not a criterion for our search. But we do expect moons to be very common.
There are no exoplanets that have moons?
Confirmed moons, but we do expect them to have moons.
Right. Huh.
Yeah.
Okay.
Yeah.
I didn't realize that the ones we'd found didn't have moons.
Confirmed moons.
Confirmed moons.
Mm-hmm. They most likely have moons. Almost all of the planets in our solar system have moons. The only ones that don't are Mercury and Venus because they're so close to the sun.
Okay.
Granted, most of the exoplanets we've found are also very close to their suns, but there should definitely be moons around planets that we've discovered. We just can't see them yet.
Oh, okay.
So that's if life formed natively on Earth. There's also this idea that life formed elsewhere and then came to Earth. That idea is called panspermia. It
had to have sperm in it? They slip sperm in there somewhere?
That's the Latin root for the seed of life.
Okay, allowed.
Yeah.
That's funny. Interesting. Yeah, I didn't realize. I didn't really connect that to. Oh,
Yeah. It's like seminary school has nothing to
you're
do with
right.
semen.
You're so right. Yeah.
So the life started elsewhere, and there are a few different mechanisms for how it could have gotten to Earth. One of them is radiation pressure, where we've talked about the charged particles, the solar wind coming off of the sun. And how it's like this massive wall that has pressure. And perhaps if you have a light enough object, that pressure from a star can transport something either within a solar system, most likely within a solar system. Although we have talked about using the solar wind to send things to the Proxima system. Who knows? The Alpha Centauri system. But that's one mechanism. More likely is the mechanism where life hitches a ride on space rocks like asteroids and comets as they travel through solar systems. So people will often talk about panspermia in the context of Mars and Earth, and how Mars used to be more habitable, used to have the criteria for habitability, and we have found some organic compounds that could be signs of old life. And maybe life started on Mars and then came to Earth on an asteroid, and we just had more favorable conditions for that life to flourish. I'm not saying that's true at all, but that's a panspermia hypothesis. And then the least credible one is that life started elsewhere and then was intentionally sent here by other life forms. People talked about that a lot with Oumuamua and the Atlas asteroid, the Atlas comet that was coming through our solar system, because scientists determined they were of extrasolar origin. They did come from outside the solar system, but they weren't sent here by aliens. They are acting like normal pieces of unintelligent space rock. So they weren't sent by aliens, and I am planning in the lecture, I want to bring up this idea that a lot of sci-fi explains how there are so many humanoid aliens in the Milky Way by saying that, there was this ancient species that seeded the galaxy with their DNA. And maybe, but probably not.
I like that as a sci-fi thing. I like that.
I like it as a bare minimum explanation for the overuse of humanoid structure in science fiction, but I will accept it. I like that better than if they provide no explanation at all.
Right.
But I wanted to mention the idea of, us being descended from aliens or aliens coming here, because it often comes up in the case of the star Sirius. There's the Sirius mystery, as it's sometimes called. I've talked about the star Sirius earlier before. It's the ones that the Egyptians called Sopdet. And it is also a star that the Dogon people are said to have known a lot about. This, however, is a myth. So the myths that people tell about the Dogon relationship to the star Sirius is itself a myth. It's very meta. It's folklore happening in real time in the modern day, and it's a cool example of ethnography gone wrong. And so we do use this as kind of a cautionary tale in folklore. At least that's how it was used for me. So a little bit about the star Sirius. It is the brightest star in the sky. It's pretty close to us, and it's not alone. It has at least one companion that we've discovered so far called Sirius B. Sirius A is an A-type star. It's a couple times the mass of the sun. Sirius B is a white dwarf star, one of the most massive white dwarf stars we've ever found. It's about the mass of the sun, but probably closer to the size of the Earth. So white dwarf stars are pretty dense, but not as dense as neutron stars, which would be the mass of the sun, but the size of like New York City.
Okay.
Yeah.
Small and hot.
Small and hot. Sirius B, the white dwarf star, was discovered officially in 1862, but they started looking for it in 1844 because they noticed that Sirius A was being tugged by something. So keep that in mind. We confirmed it in 1862, but knew about it from 1844. It has a 50-year orbit. The two orbit each other roughly every 50 years. Now, in the 1930s through the 1950s, two anthropologists, Marcel Griol and Germaine Dieterlen, I'm probably not saying those names correctly, but I don't care. They visited because they didn't care to get the details of their work correct.
Yeah,
so
I was like, I already know where this is going. I saw the map and I was like, oh no.
So these anthropologists go to visit the Dogon people who live in Mali and Burkina Faso, and they spend many years, over a couple decades, learning about their culture. In 1948, they published this book based on conversations mostly with one hunter from the Dogon tribe. And the book is called Conversations with Ogotameli, where they claim that the Dogon have this advanced astronomical knowledge. They know that Sirius A is actually a binary. In some stories, they even say that it has multiple companions. So they know that it's not just a single star. Marcel and Germaine, they claimed that the Dogon knew about the Galilean moons around Jupiter and that they knew about Saturn's rings. And I don't mean to take away from their intelligence or from their astronomical knowledge, but these are all objects that you can really only see with telescopes. Sirius B is so dim that you need a telescope that's at least like 5 inches across to see it. Even if Sirius B was brighter in the past, even if they were naturally gifted with really good eyesight and they were using techniques like looking out of the corner of their eye, because your peripheral vision is better at detecting the difference between light and dark than your straight on vision, which is better for like fine detail. So even if they were doing all of those things, it's very unlikely that they would have been able to see Sirius B. But still, Marcel and Germaine make this claim in 1948. They also claim that the Dogon were visited by aliens who originated around Sirius, called the Nomos, and that the Nomos gave them this information, and in some stories were even like the ancestors to the Dogon. So Germaine and Marcel, they publish this. It gets kind of popularized and picked up because in 1976, a man named Robert Temple writes The Sirius Mystery, where he shares all of Marcel and Germaine's findings and really popularizes the idea that the Dogon have this connection to aliens from Sirius. We know that this is false because in 1991, another anthropologist, Walter Van Beek, went back to visit the Dogon with a couple other anthropologists and tried to confirm this and couldn't. They found that some people in the tribe knew what these stories were or knew what they were talking about when they mentioned them, but most didn't. And even the ones who did know about it, the details were inconsistent. So Walter Van Beek went back to Germaine Dieterlen, who was still alive at the time, but Marcel Griol was not, and was like, "Hey, Germaine, do you want to defend yourself? Because I'm about to publish this paper saying that your findings are wrong. Do you have anything to say?" And all Germaine had to say was, "Please don't publish it."
Bro.
Right. So this isn't real. What most likely happened was that in 1893, there was a solar eclipse, a total solar eclipse that passed over Mali, and which would have brought a lot of astronomers and astronomy enthusiasts to the area, and they could have told the Dogon about Sirius B and about Saturn and the Galilean moons while they were visiting for the eclipse. And then 40 years later, when the Dogon were talking to Marcel and Germaine, this is the information they had. Or it's also very possible that Marcel and Germaine knew this stuff about Sirius themselves, and they kind of inserted it when they were talking to Ogotameli.
Yeah, I knowing the stories that we do know about how anthropologists have come into especially African communities, I wouldn't be surprised if either they just put it in there or the guy just told them so many, he just told them whatever. I could also imagine the tribe, the guy being I'll just tell them whatever. And they just they didn't know what to do with it. So they put in something that they knew.
Exactly.
To make it seem they were, I don't know, they wanted to discover something, right? Who's going to check them until 1991?
Yeah, they didn't know about Walter yet. And so, yeah, it's so interesting to me because this comes up. People will ask me about the Dogon, or I've seen some astronomers talk about the Dogon because we want to share that there's indigenous knowledge about space already. But this is just, it kills me because I want this to be true, but
Like they didn't have telescopes, right?
Right.
Yeah.
Like I want it to be true, but it's just not. And instead, it's an even more interesting story about how we need to be really careful with our ethnography and anthropology work.
Definitely.
But that myth aside, we are still trying to find aliens. Since the 1960s, astronomers, people who work for SETI, the Search for Extraterrestrial Intelligence Institute, their roots go back to the 60s. And a big tool that we have in the search for life is the Drake equation.
No.
For the lecture, I have a picture of Drake, and then the no cancel sign, and it's a picture of Frank Drake, and be like, no, it's this Frank Drake, the astronomer. However, I did host a couple times SETI's Drake Awards, and I told my college roommate Lauren that I was hosting the Drake Awards, and bless her heart, she has so much confidence in me and my career. She thought I was hosting an award show with Drake the rapper.
Wow, that he had his own award show, and that you were like co-hosting.
I was hosting it.
Right. Yeah. Like he was the sponsor. Like it's his name on it, but he's gonna be there. But then you are the actual MC of the night. Yeah. Okay.
And that would have been fine. It would have been fine if it ended there. But she then told her whole family that I was hosting an award show with Drake the rapper. So then when I saw her family next at her wedding, they were like, Moiya, how was Drake?
Wow. Wow. And then like before or after the beef? This must have been before.
Oh, it was before.
Okay.
They were white. They didn't know about the beef.
She would have had some different questions if it was after.
They didn't know about the beef.
Fair.
So yes, it's not the rapper's equation. It is Frank Drake's equation that he came up with in 1961. And it's not even an equation in the traditional sense. There is no answer to this equation. It's more of a thought experiment. And Frank Drake he came up with this when he was designing an agenda for a conference in 1961 to be held at the Green Bank Observatory in West Virginia. And he decided to split the conference into 7 different sections where they would each discuss a different number they would need to know if they wanted to know how many intelligent communicating life forms there were in the universe. And so if you combine all of these factors, you get that number. So the first factor is how many stars form in the galaxy. Like, what's the rate of star formation? And then you have to figure out around those stars, how many planets do we expect to form on average? On those planets, how many do we expect to have a habitable environment? Within those environments, how many do we expect to generate life? And then how many of those life forms do we expect to become intelligent? And then of those intelligent life forms, how many will learn to and start communicating? And then the final term is the average length of a civilization. If there is some great ending event that makes civilizations not last very long, then our chance of communicating with someone else does go down. So those are 7 different numbers. If you multiply them all, you get the number of intelligent communicating aliens in the galaxy. And we only know 2 of these values, 2 of these 7. We are pretty sure that the Milky Way forms like a handful of stars every year, and like up to 10 stars every year, and that the average star has a couple of planets around it. And we don't know the rest of the values. So we're actively trying to figure those out. And I do have a friend, Seven Rasmussen, who has a book coming out this August, a couple weeks before my book. It's called Cloudy with a Chance of Starships, and it explains the Drake equation. It's called How the Drake Equation Reveals the Odds of Life in the Cosmos. So check that out. I know it's available for pre-order. It's called, again, Cloudy with a Chance of Starships.
Great title. And yeah, because how do you find out the answers to those questions? And then to say that if you multiply them all, you can get a number. So we can't use it for the life we know about here on Earth. Is that the case?
No, it's all extraterrestrial.
Oh, okay.
But you ask, how will we know? How can we know? There will be signs. There will be signs of life. And we are looking for the signs. We broadly separate them into two different categories, biosignatures and technosignatures. Biosignatures are natural signs of life. They're usually going to be chemical, and it depends on the type of environment you have. So an environment like the Earth, we can tell that there are biological processes happening on the Earth because we see a lot of oxygen and a lot of ozone, and we see a lot of water vapor in the atmosphere. And those are produced biologically in these abundances. There are other processes that can create these molecules, but maybe not at this level, maybe not in this combination. And so depending on different environments, you would look for different chemical fingerprints of life. For example, phosphine in the upper atmosphere of Venus. I think back in like 2020, 2021, people were talking about that a lot. And phosphine is a potential biosignature because here on Earth, it's usually found in like, honestly, landfills and like garbage dumps because of those bacteria that, you know, are in that area, and they produce a lot of this phosphine. So that's a potential biosignature. A technosignature, instead of being a natural sign or an organic sign of life, is a sign of environment manipulation. One of the most famous examples of this is the Dyson sphere, which is the idea that as a society gets more advanced, it's going to need more and more energy to sustain itself. And the max amount of energy that you can collect is from your star. So if you build a megastructure of solar panels that surround your star and capture its light, and then you can use that energy, then you can power your society. That's a Dyson sphere. That's very extreme. We could potentially find those by looking for places where we don't see a lot of optical light because the physical structure is blocking the optical light, but the structure would then heat up and glow in the infrared. So if we see a bright infrared source of light where there is no optical source of light, potentially we found a megastructure. But there are other signs of environment manipulation. I remember seeing a paper when I was in grad school where scientists were using light curves, the transit light curve data that I love so much. They were using it to try and find evidence of nightlife lights. Like when you see that map of the U.S. at night and it's all those bright lights, they wanted to find that on exoplanets.
They just they use a different kind of light, so we can't see it. So we got to search for it in the infrared.
Well, no, we're not on the Dyson sphere anymore. This is a completely separate method where for like a whole separate paper where people were trying to use light curves to find evidence of those city lights at nighttime, which is just hilarious to me. We've been looking. We can look through space-based telescopes, the Transiting Exoplanet Survey Satellite, or TESS. We haven't covered it yet on the pod, but we will for sure soon, or at some point. And it is kind of like the next generation's Kepler telescope. It's out there right now, actively searching for exoplanets. The James Webb Space Telescope is able to look at the atmospheres of some of those planets so we can study them, you know, maybe look for biosignatures and just get a better idea for what the real surfaces of them or their real atmospheres are like. And we can also study them from the ground. This is the Green Bank Telescope, my favorite single dish ground-based telescope.
That seems like a lot of superlatives there.
I did. There's another condition that I could have added that I didn't. So,
do we need to do an episode on your favorite telescopes?
Oh, my ranking? That'd be messy. Listeners, if enough of you want it, we will do it. But you have to tell us that you want it.
You have to tell us very specifically.
So we've been looking for 60 years and we haven't found anything. And that doesn't mean life isn't out there, but it does mean life isn't everywhere. So it's precious and we should celebrate it and study it and honor it in the way that we know how.
In theory, life could spring up on a planet somewhere, starting anew now, because it took bajillion years. And so now it could be, any moment could be the bajillionth year for new life in the galaxy. So it may not already exist, but it could spring up.
It would be extremely unlikely for the second ever to form 4 billion years after the first ever. So
Okay.
yes, there are almost certainly life forms that are coming into existence now on young planets. But if that's the case, then there's no way that they are the only other life forms. We have this idea in science. Things can happen 0 times. They can happen infinity times. The process can be very common, or it can happen once. It's not going to happen twice. So if something happens twice, then it's happening infinity number of times.
Huh. That does make sense. Interesting.
People have different ways of celebrating life and welcoming spring all over the world. You can dye eggs. You can plant new things. Plants, yes, but also hobbies or habits. You can do a lot to dispel winter. You can do a deep clean. You can do some self-reflection. I think that this is the right time of year to actually start something anew, to have resolutions, to set goals. January 1st is not the right time. So
that's an admin one. It's for taxes. Yeah. This one's for renewal of life.
For renewal of life. And now hopefully you have a better sense of where that life came from, so you can renew it more informedly.
Renewed, morid, informedly.
This is the latest we've ever recorded an episode. I've been working on this lecture all day. So, but yeah, how do you think that lecture will go over with the students? Is there anything I should add? Any questions you still have left lingering?
I think that's great. Perfect time of year for it. I had a question that you did answer about like life potentially forming now based on what you had said. I was curious about that. And then my other question is, so when we're looking for life, are we looking for, you mentioned like all those different levels of livability. Are we looking for all of those levels, or is it just the like lower ones, since we kind of think we know that like there aren't higher life forms? So like, are we looking for something that's more on like the cell level? Like, are we looking for things that are similar to what our beginnings were to try to find it at that stage? Or is there like a later stage?
We're looking for anything we can find.
Right. Yeah. Yeah.
Just anything.
Do different scientists study different aspects of life, like to look
absolutely.
for it? So someone will focus on like one different kind of like a few different biological manipulation type things.
There are people who would look at specific genes. There are people who would look at specific environments. There are people who would look at specific time periods. So yeah, like everyone is approaching it from very many angles.
Wow. Very cool.
Okay. Well, I'm glad you liked the lecture. And I'm excited to give it. And hopefully the students learn a lot. But listeners, no matter where your life started, no matter where it ends up, your space along the whole journey.
I love that.
All right. Bye, everyone.
Bye.
Happy spring.
Happy spring. We did it.
We did it.
Pale Blue Pod is hosted by Dr. Moiya McTier and Connie Gibbs. Moiya created the show with the funny and talented Karine Caputo with help from the Multitude Productions team.
Our theme music is by Evan Johnston, our cover art by Shay McMullen, and our audio editing is handled by the superlative Misha Stanton.
Stay in touch with us and the universe by following @PaleBluePod on Instagram, or check out our website, palebluepod.com.
I, Moiya, am Go Astro Mo on all socials.
And I'm @ConStar24 on Instagram.
If you want to support our show, join our community at patreon.com/palebluepod, or send this episode to your family and friends group chats.
We're a member of Multitude, an independent podcast collective and production studio. If you like Pale Blue Pod, you will love the other shows that live on our website at multitude.productions.
Thanks for listening to Pale Blue Pod. We'll be back next week.